Okay, elementary principles of memory elements. Okay, memory elements are made up of tiny logic gates in specific configurations. So we're first going to look at the two primary building blocks of these memory elements. First is the NAND and second is the NOR. Okay, now if we think back to grade 10 and 11, we've got two inputs to a NAND gate and my output is X, and we look at the truth table where A and B are the inputs and X is the outputs. X is the output, and we look at all the possible input scenarios. We see that we've got a 1 on the output whenever there's a 0 on the input. So to summarize this one, we're going to say 0 in gives us 1 out. For the NOR, again very simple, we've got A and B on the inputs, there's the symbol, X as the output, and if we look at the truth table, we will see that whenever we've got a 1 on the input, we get a 0 on the output. Okay, so 1 in gives us 0 out. This is very important to remember for the rest of this chapter. Active low. What that means, if my input changes from a 1 to a 0, that's when my output is going to change from a 0 to a 1. So the active low occurs on the falling edge, whereas the active high occurs on the leading edge. Okay, for the RS active low, for the RS active low, we've got the following: set and reset, those are both knotted. That goes into a NAND gate, which then feeds into my queue. The reset also goes into a NAND gate, which then goes into my NOT queue as my output, and then I've got the same crisscross latching that occurs with the RS active high. Okay, symbol, set and reset, both knotted, that goes into queue and not queue, and that is the symbol or the blocks diagram for the RS flip-flop. Now the way that this one works, set is always equal to Q when it comes to the active high. For the active low, on the other hand, we've got the reverse happening. You're welcome to go figure this on your own. We've got set and reset, both knotted, 0 0 0 1 1 0 1 1, and we've got Q and we've got not Q. Okay, so remember these two are knotted, so if I apply a 0, it sees it as a 1, and if I apply a 1, it sees it as a 0. So set and reset are equal. So that's a 0 and that's a 1, 0 and 1. Apologies. The input on the set is equal to Q. Okay, very important to remember, set and Q, or S and Q are always the same. Alright, now when I put 1s on the input, because these are NANDs, the outputs switch to 0, and that puts this into the hold state. Okay, we don't use the 2 zeros on the input, as these 2 zeros will force a common value for Q and not Q, so this is my illegal state. Okay, this is my set, and that is my reset. Okay, when looking at these, it's best to look at them as a consecutive process. So first put it in the set, then go into the hold stage, and then go into the reset, and then maybe go into the legal state to see how that is going to influence the operation.